Good evening, ladies and gentlemen. Thank you very much for giving me voice. Today I will talk about storage methods of hydrogen. And the base is based on work on Professor Ubong Edward from University of Saskatchewan in Canada and published in recent number of International Journal of Hydrogen Energy and critical review on the current technologies for the generation, storage, and transportation of hydrogen. The work is saying how in the about recent 5 years achievements in this phase, because more than production and feasibility is trouble of storage, because gas is very light and hard in even the most storage tank. It releases partially some hydrogen if not used. So the big challenge is to produce this hydrogen transfer into way and the breaking during the linkage transportation. Here is the several methods about state-of-art, detailed discussion on hydrogen production, storage, and transportation is presented, and discussing about kinetic cyclic behavior, toxicity, thermal response, cost effectiveness, and new active techniques are mentioned as ultrasonic irradiation, allowing ultrasonification, controlling plasma methane reaction are employed here. And still a very initial point, so this is very difficult. And since fossil fuels are depleted, there is needs to change and to renewable like wind, solar, and nuclear to provide and wherever location constraint is made that wind and solar and nuclear cannot be everywhere used, so there needs to be connection and combination of different to fulfill human demand. The free hydrogen production methods are classified into three types as hydrogen from hydrocarbons, including fossil fuels and biomass, hydrogen production by the direct splitting of water, and hydrogen production by the direct reaction of chemical reagents such as metal, acid, and base. These hydrogen production methods present advantages and disadvantages of one another. Therefore, this review will highlight and positive and negative parts of each of these mentioned above methods. High flammability limit in the air compared to gasoline vapor and natural gas. Also, its high explosion limit in the air compared to gasoline vapor and natural gas, 6 to 14%, while air 4 to 74. These are the safety rules. And following this, hydrogen can be stored traditionally in gases or liquid form in pressurized or cryogenic tank. Ericsson et al. Summarized that as energy storage in power systems that use intermittent renewable energy sources, wind and solar, to generate electricity. The results demonstrate that while they still require large cost reduction to become uh, commercially attractive, however, are technically feasible. Besides these conventional methods to store hydrogen, extensive research on storing shows promising results. And finding a suitable means to transfer hydrogen as an integral part of our hydrogen economy. Various means of hydrogen transport, such as pipeline, blending natural gas, and cryogenic tankers, and new methods are mentioned. Hydrogen production methods. Firstly, they discuss about fossil fuel as hydrogen carbon reforming, instead methane reforming. So methane is going through water and break such produces syngas, hydrogen, and carbon dioxide. This production generates much carbon dioxide, which is greenhouse gases. So this is not favored to the environment right now. And this is the these auxiliary reactors can be steam, and the reaction oxygen is steam reforming and partial oxidation endothermic reactions. Moreover, combination of these are autothermal reaction, so this combination are preferred. It is the most used method in industrial hydrogen methods in industrial hydrogen production. The conventional process consists mainly of three processes: synthesis of gas production, water gas shift, and gas purification. In feedstock contain organic sulfur, there is need to avoid poisoning of reforming catalyst, nickel-based catalyst, with the carbon deposition. So we have another issue of fossil fuel to replace, where char can be replaced in future. So this the trouble of hydrogen is that gasoline and natural gas is much more denser, 10 times in case of gasoline, and natural 4 times, and has also lower boiling point in minus 253 and explosion limit between 19 to 60%, while gasoline only 1 to 3.3, as well natural gas 6 to 14%. Flammability limit is from 4 to 74%, while gasoline and natural gas only in case of gasoline 1.4 to 7.6, while natural gas from 5.3 to 15%. So these are the trouble that are flammable and explosive gas. And this in product design needs to be also taken care to the design. This the another process as methanation, so we have following way. We get a fuel and reform. This reformer is by heat recovery and steam oxygen is given, and shift conversion takes carbon dioxide and hydrogen. Another way can be also natural gas into desulfurization, reformer, heat reforming, sheet conversion, also so like here by steam or oxygen, and pressure swing absorption. In both methods, we have side products, carbon dioxide. As this case is typical is both natural gas and steam, with catalyst and refractory and burners, which burn this methane that breaks into hydrogen and carbon dioxide. The hydrocarbon dioxide is partially oxidation unit given by steam or with oxygen, shift conversion, and purification separation to hydrogen and carbon dioxide usually by swing pressure absorption. And this is one. The other case is by renewable sources. And firstly, they discuss the biomass renewable sources to break or by environmental as crop residues or animal waste, organic municipal solid waste, but also furniture, all skin or ternary waste residues, animal residues. Biomass plays an essential role in energy supply and it represents about 40% of worldwide energy generation. Two main methods that are used hydrogen from biomass are thermochemical and biological, and technologies to transfer these parts to hydrogen. Thermochemical method is thermal decomposition, includes pyrolysis, gasification, and liquefaction. In liquefaction, we use liquid for on high temperature fire in supercritical form to break these compounds into hydrogen, while pyrolysis and gasification used in case of hydrogen use only temperature with addition or energy by heat or like microwave, where, for example, energy by heat of temperature upper between 300 to or 200 to or 2000, and if we add some oxidation, we change this process called gasification. The gasification can make more waste decomposition, but also produce some oxide, which are most sometimes very toxic, which doesn't occur so often in case of pyrolysis. Therefore, we have more safety and preventive equipment in case of gasification more than pyrolysis, making it much more expensive. And this is firstly by pyrolysis and says that it gases biochar, which can be used as fertilizer or or improvement, like here to separation use, and this can be the production is liquid to air to from 50 to 25% between cases to liquid. Usually, but are different in case of catalytic or not catalytic. Which catalyst, as this is found, easily is toxicated, and this is trouble that are not very still green methods of production as catalyst. The another biomass gasification as stored use some high oxidate and gasifier could stated that dolomite, olivine, and char inside can hinder transformation, making more more gases and less toxins. As part of pyrolysis, they talk about using the giving energy mm, by sun, by solars, by reflection of light, and one another is photolysis, which is both by biological methods, transfer as well, and initially because they don't talk only by using they undergo to biological methods as biophotolysis, protofermentation,